morning, students. Welcome to the online classes of St. Anthony's and St. Peter's High School, Saturday. Today, I am going to teach second lesson, friction, from 8th class. Today is the day 1 session. See, in the last lessons, in the last unit, we have studied about force and how force acts on the body, how the force affects the motion or state of an object, rest, or how the force brings the body to rest or into motion. And also we have discussed about the types of forces, contact forces and various field forces we have discussed in our unit 1. This chapter is about frictional force. It's a type of contact force as we discussed earlier. Friction force comes under contact force. And we also have studied that frictional force opposes the relative motion between the two surfaces in contact. In this chapter, we will be studying about what is friction and the 3 types of frictions. One is static friction, sliding friction and rolling friction. And we will also study about how, is friction necessary or helpful in our daily life? If there is no friction, is there any necessity of increasing the friction? If we want to increase the friction, what are the things to be done to increase the friction? How we can increase friction? And also, if friction is more, how to decrease friction? And we will also study about identifying factors influencing the fluid friction. Fluid friction is also a type of friction offered by the fluids. We will also discuss about this fluid friction and how it influences. Before going to the topic, first of all, let us start again with what is friction. Let me take an example of, I have a book. Let me keep this book on the table. Now, if I keep this book on the table, this is my book. I have kept it on the table. Here, 2 things are in contact, physically contact. That is the book surface and the table surface. Now, I will apply some force on the book. When we start applying force on the book starts moving on the surface of the table. Now, when there is a physical contact between book and the surface of your table, because of the applied force, the book will be moving in this direction. Then the surface of your table offers a frictional force, or it exerts some force which opposes the motion of the book. That means the direction of the motion of the book is in this direction, I suppose. As the applied force is in this direction, the book also will move in this direction. Now, if the book started moving in this direction, the table offers a resistance or offers a force in the direction opposite to the applied force. This force offered by the surface of the table can be called as frictional force. Is it clear for everybody? Now, that's why I say frictional force opposes the relative motion. I say it as a relative motion because the term relative means here, with respect to the surface of the table, book is in motion. Now, if I say I keep my book on the table. Now, my book started moving when I pushed the book. When I apply some force, the book started moving. With respect to the surface of the table, the book is in motion, right? So always I say a body is in motion or rest only with respect to something. I am comparing whether it is in rest position or motion only with respect to another object. I will say about its state with respect to some other object. So that's the reason I call it here. It opposes the relative motion. So here, when the frictional force comes into act, see, usually it is caused by the irregularities on the two surfaces. For example, irregularities is nothing but ups and downs. See, if I take a marble, roll on a smooth floor, it moves on the smooth marble floor. But if I take the same marble and I make it to move in the sand, here I'll repeat it again. I am taking two marbles, I am making one marble to move on the smooth marble floor and the other marble in the soil, sand. In these two situations, which marble will move very smoothly and fastly? And which marble will slowly move? It's so obvious that the marble which is made to move on the smooth marble floor will move fastly when it is compared to the marble which is made to roll in the sand. It is because the sand is rough surface when I compare with the marble floor. Marble floor is a smooth surface. Your sand will have small stones, irregularities, ups and downs will be there on the surface of the sand. Because of the irregularities on the surface or ups and downs on the surface, the object or the marble cannot move smoothly because it is obstructed or opposed by the irregularities. It opposes the motion of the marble. So I can say that friction offered by the surface is not same in all the cases. On smooth surfaces, friction will be less. On rough surfaces, friction will be more. That friction will be more because of it is because of the ups and downs of the surface or irregularities on the surfaces. So friction is usually caused or more on rough surfaces when it is compared with the smooth. So, is friction necessary or not? Why we are learning this in our 8th standard? Why we have a special unit friction in our 8th standard? What is the importance of this chapter? Why we have to learn about friction, especially in a unit? See children, now I am able to walk on the ground. We are able to construct buildings. It is all because of friction. If there is no friction, I cannot do anything. I cannot hold a chalk piece in my hand. I cannot write because there is a grip between my finger and the chalk piece surface. Here the chalk piece surface and my finger surface are in physical contact. When I am and my foot surface and the ground surface are in physical contact. When I am moving on one another on the other surface, I am moving in certain direction, and my motion is obstructed by the surface of the ground. If it doesn't happen, suppose we slip off. we cannot walk. Let me take my car. I am moving in my car on the road. The tires of my car and the surface of the road are in physical contact, and the car started moving in the forward direction. When my car started moving in the forward direction, my direction, the motion of my car is opposed by the surface of the road. If at all my surface is so smooth and the friction offered by the surface is very low or zero, if I say, my car cannot travel, my car cannot move forward, it slips off, and I will meet with an accident. That's the reason. See here, when I am able to walk on the ground, right? Let me take my situation will be changed if I walk on the banana peel. What happens when I step on the banana peel? My surface, my road surface has been changed now to the banana peel. Here in this case, the banana peel offers lower friction for almost zero friction. See, actually, when the banana peel, my ground surface is converted to the banana peel. Now in this situation, as it won't oppose my motion, I slip off. So here I can say friction is necessary here in this case to some extent. Let me take an example of carom board. Without lubricant, we use powder, right, for the smooth movement of the coins and the strikers. We use powder. We sprinkle some powder on the carom board so that our striker moves very smoothly along the carom board. Suppose if I don't use any powder, if I don't sprinkle any powder on the carom board, what happens? The striker cannot move easily. Am I right? So why do you think? What happens? I mean, what is happening to the carom board when powder is sprinkled on the carom? The carom board has been converted to the smooth surfaces, so the coin can move. Because here in this case, smooth surface indicates that the friction offered by the surface will be reduced by smoothing the surface. Like the previous example, what I took for a marble. When my marble is made to move on the smooth marble floor, it moves very fastly, easily. Whereas my marble is allowed to move in the sand, it doesn't move because the friction offered by it is more. So now you tell me, is friction necessary or not? Definitely friction is necessary. If friction is more, irregularities are more, ups and downs are more, can my marble move? Yeah. So I need to reduce the friction. Now in the example of banana peel, the friction offered by the banana peel is very less, as it is a smooth surface. Usually when we walk on the soapy water or when muddy surfaces in rainy seasons, what do you observe? We slip off, right? Why do you think we slip off? The surfaces are smooth, they become smooth when it is muddy surfaces or on soapy surfaces or on smooth surfaces. When the surface is wet in our room, usually we do fall down, right? Why do you think we fall down? It is because the friction offered is very less thick. We should get a doubt that in the before example, as friction is more, in the carom board example, we sprinkled powder to reduce the friction. Right? Now what we are doing on the banana peel or on the wet surface, the friction is very less. Right? wipe the wetness, we wipe off the water to make it rough. It means here friction should not be more, friction should not be less. Friction is necessary but not more or not less. Depending on the situations, depending whether the friction is less or more, we need to adjust. If the friction is more, we should reduce it. If the friction is less, we should increase it. Now, let me take another example of matchbox. If I take the matchbox, I take a matchstick and strike it. Why do you think you strike it? Without striking, can you get fire? Can you ignite it? That friction causes, because of that friction only, we are able to ignite the matchstick. And did you ever observe the sole of your shoes? You have some grooves there, ups and downs on the shoes. That ups and downs on the shoes, or the irregularities on your shoe sole, helps us not to fall down or slip off, and we can move easily without slipping. That's the reason we have spikes or grooves on our shoes. Here, in order to balance the friction. So, friction is necessary, but not more, not less. And also, in another examples, we use lubricants in automobiles. For tiring machines or for cycle, we apply grease to the cycle chains. And we also apply some lubricants with oily things into the machines, so that to reduce the friction. So, here, from all these examples, we have learned that friction is important in our everyday life. The conclusion of this session is, friction is that force which opposes the motion of a body, and friction is necessary in our daily life. It is good to have it, and if we have it more, it is not good. So we need to balance it. If it is more, we need to reduce it. If it is less, we need to increase it. We have some methods to increase and decrease friction. In the next sessions, we will be dealing with the types of frictions. We have 3 types of frictions already discussed: static, sliding and rolling. In the further sessions, we will be learning about what static friction and sliding friction and rolling frictions are. Thank you. Meet you in the next session.